list out here. So the first one here is JVM architecture. After that, we'll go with the Java download and installation. So next one is very important, setting the path environment variable. There is a path environment variable. What is the use of this? We'll discuss. After that, okay, we'll go with the Java program explanation. Okay, Java program explanation. Sandeep, can you hear me?
Yes, sir.
Okay, fine. Yeah. So the topics we're going to discuss today actually. What is the first one? JVM architecture and Java download and installation and setting the path and variable and Java program explanation. Okay, each and every modifier will explain the small Java program. Okay, let's start with the JVM architecture. See, so if you observe, yesterday we discussed it, right? So we have a source code. Okay, I want to name it as add.java. So what it is a source code. Okay, so let's assume here we have a mission. I want to execute the Java program in the computer. It will not execute directly because computer is an electronic device which can understand only 0 and 1s. Okay, so the computer cannot understand what is the Java code and C programming and C++. So for that, we have to convert this Java program into the machine language instructions. So for that, in Java, we have a Java C compiler. When I'm giving the .java file to the Java compiler, so what it will generate? It will generate the one intermediate file called a .class file. Okay, a .class file. Okay, what this .class file contains? This .class file contains the bytecode instructions, not machine language instructions. That you remember, it contains the bytecode instructions. Okay, so again, when I'm taking this .class file, okay, and running on the computer, it cannot understand what is bytecode instructions. Like what are the bytecode instructions? Okay, a computer can know only machine language instructions. Again, we have to convert this bytecode into the machine language instructions, nothing but zeros and ones. Then who will convert this bytecode into the machine language instructions? So for that, yesterday we discussed, right, there is a JVM. It is a one program, Java Virtual Machine. Okay, what is the full form of the JVM? Java Virtual Machine. Okay, now when I'm giving the .class file to the JVM, okay, JVM internally convert the bytecode into the machine language instructions and it will execute the program in the memory and it will give the output as a, okay, so here it will give the output for that Java source code. Okay, now here what we are going to discuss here is very simple. So when I'm giving the .class file to the JVM, okay, we are giving the .class file, this .class file to the JVM, what JVM is doing internally, that we are going to discuss now. So the internal architecture of the JVM here, when I'm giving the .class file to the JVM, so how the JVM will, okay, so converting bytecode into the machine language instructions here, very important. In the interview perspective, they'll ask what is the, okay, explain about the JVM architecture, then you have to explain the internal architecture of the JVM. Now listen carefully. So I'm taking the, so this whole thing is called JVM, very simple, okay, Java Virtual Machine. So what is the input for this JVM? .class file, right? I'm writing the .class file here. I'm giving the .class file to the JVM. Now what JVM will do here? Okay, first of all, let me draw all the components which are in the JVM. The first component here is class loader subsystem here. What is that one? Class loader subsystem. I'm writing the, okay, the component name, class loader subsystem. So what is the duty of this class loader subsystem? I will explain later. In the same way, so this JVM contains a, okay, memory areas. Okay, JVM contains the memory areas. The first memory area here is excuse me. Okay, method area. Second one is a heap memory. We'll discuss each and every memory area. And Java stacks. After that, PC registers. And finally, here we have, okay, native method stacks. Okay, so what is the first one? First one is a method area. Next one is a heap memory. And the third component or third memory area is nothing but okay, so Java stacks. After that, we have a PC registers program counter. Okay, PC registers. And here native method stacks. What is in the native method we'll discuss. Okay, native method stacks. So these are the 5 memory areas we have. Now after that, so there is a execution engine. Okay, so this is a very important here. So this execution engine, okay, converts the bytecode into the machine language instructions here. Okay, so this is the main part actually. I'm writing the here execution engine. So along with this, okay, we have a native method interface. There is one program, native method interface, and there is a native method library here. Okay, so this for native method stacks. So here we'll see here. So what is this one? Native method interface. And here native libraries. So I'm writing the directions here. I'm drawing the direction. So here bidirectional, and in the same way, so we are take to this class or subsystem from this memory areas. Next one, in the same way, execution engine to the okay this memory areas. You can take direct like this one bidirectional. In the same way, so native method interface to this execution engine, and here also bidirectional only. In the same way, okay, native method interface to this memory areas. This is also bidirectional, and this is only single directional native method libraries into the native method interface. Okay, that means so this native method interface is a program, so it will load this native libraries into the JVM. So what is the use of the native libraries? We'll discuss here. Okay, so this is a whole structure of the JVM actually. See, internal architecture of the JVM, very simple. Now, so let's start with this first component, class loader subsystem here. Okay, so what is happening here is, so when I'm giving the dot class file to the JVM, in the JVM there is a component called a class loader subsystem. So it will receive the dot class file and it will perform some operations here. So what are the operations it will perform here? Very simple. So it will perform 3 operations majorly. I'm copying this. Okay, so what are the operations it will perform here? First operation, so it will load the dot class file into the main memory, nothing but RAM. That's the first thing. Second thing here is, after loading dot class file into the RAM, it will verify the bytecode instructions, okay, to check whether the okay bytecode instructions correct or not. Okay, if everything is fine, then this class loader subsystem only allocate the memory for the Java program, entire Java program. Okay, in the end of the last, what is the duty of the class loader subsystem in the JVM? Then what to tell? The first point here is, so it will load dot class file into the dot class file into memory, main memory, that is RAM. Okay, after loading that class file into the RAM, so what is the next step it will do? So it will verify the bytecode instructions of the dot class file. It verifies bytecode of that class file. If everything is fine, okay, it will allocate the okay memory for the Java program. Okay, it will allocate Okay, the Java program here. Okay, these are the three things the class loader subsystem will do here. Okay, listen here. I'm talking about the memory. I'm talking about the memory here. Now, the memory which is allocated by the class loader subsystem. Okay, the memory which is allocated by the class loader subsystem is divided into 5 categories or 5 parts. And these 5 memory areas are called runtime data areas. Runtime data areas. Okay, who is allocating the memory? Class or subsystem is allocating the memory for the Java program. So there are 5 parts, 5 memory areas. The 5 memory areas are called runtime data areas here. Now we will discuss each and every memory area. Let's start with the method area, then followed by the heap, and so later we'll go with the remaining memory areas. Okay. Now let's start with this first one. I'm copying this one. See. Okay, so in order to explain this memory areas, I need one Java program actually. Okay, that's why I'm writing the one Java program here. A typical Java program contains like this here. Class test I'm taking, and I'm taking the variables like int x equals to 10. You will come to know, okay, how to declare a variables and how to create the classes. Okay, so just for explaining this one, I'm taking small program. Okay, don't worry about this one. And a class can contain the functions, nothing but methods. For example, we have a m1 method and there is a m2 method. Okay, a class can contain the properties and methods. Properties nothing but variables. These are the variables and methods. Okay, assume that. Okay, now so we have a class. It is a class here. Now when I'm giving the dot class file to this JVM, so what is happening here? So the class loader subsystem will take the dot class file and it will load into the memory, and it is allocating the memory for the that Java program here. Now, so what this method area contains? Okay, what it will store? Very simple. So this method area will store the okay the class code and variables code and methods code in the form of bytecode instructions. Coming to the JVM, JVM will receive the datless file only, not source code. Okay, I'm writing the source code here, but the equivalent bytecode it will store into the method area. Okay, so what is the method area it will store? So class code, the entire class code and variables code and methods code in the form of bytecode instructions. That's why the name is a method area. Okay, I'm writing here. See, it will store class code and variables code and methods code in the form of bytecode instruction that you remember here. Okay, so we are talking about the bytecode instruction only now. So what is the main area, what is the duty of this method area? So it will store the okay so class code and variables code and methods code in the form of bytecode instructions. That is a okay, so that is the duty of this method area. Now what is the use of the heap memory here? Okay, what is the use of the heap memory? Listen carefully. Okay, we have a class. In a class, we have one variable and two methods. I want to make use of that methods and variables. Okay, now what we to do? So whenever we are creating the object, then only I can make use of these methods and variables. Otherwise, I cannot. Now, so in order to use, okay, in order to access m1 or m2 or x variable, we have to create the object for this class here. Okay, later we'll come to know okay so what is the object and class, but remember here in Java, so we can create the object for a particular class based on the new keyword here. So there is a syntax. I'm writing the syntax here. See, class name, what is the class name? Test, and a reference variable t, okay, equals to new keyword. Okay, we have to use the new keyword. Okay, we have to use the new keyword. Okay, and then followed by the class name here, then followed by the class name. This is a syntax for creating the object in the Java. In this case, what will happen whenever this statement is executed? Okay, one object will be created like this here. Okay, one object will be created in the okay like this, and what are the okay properties and method it contains? Whatever the class is having, the same thing available in the object. Okay, What is that one? X and M1 and M2. Okay, where this object is created here, and this object is pointing to the reference variable called T. Okay, where this object is creating actually. Okay, so these objects are created for a class in the heap memory. Okay, so these objects are created inside the heap memory. That is the purpose of the heap memory here. Every object, not only this test object, student object, employee object, customer object. If you are using the new keyword, okay, so there we are creating the one object. Those objects will be created inside the heap memory. Okay, so that's the thing you have to remember here. Here objects will be created. Okay, this is about the second part. So coming to the Java stacks. Okay, so we created. Now I want to execute the M1 and M2 method. How can we execute the M1 and M2 methods here? Here we have a reference variable. If you observe, T is a reference variable. So by using the T, I can access the M1 method, M2 method, and X variable here. See, I want to execute the M1 method. How can I execute? T dot M1 method, so that M1 method will be executed on the particular object. Okay, in the same way, T dot M2 method, so M2 method will be executed. Okay, my question here is where these methods are executing here. Okay, these methods are executing on the Java stacks. Okay, we have a Java stack component, so here, so the methods will be executing here. Very simple. So Java stack is nothing but one memory area like this here, first in, last out. Okay, like this, and these stacks are divided into several frames like this. On each frame a separate method will be executed. Okay, on each frame a separate method will be executed. For example, here we are calling the this m1 method. Okay, then what will happen? So one m1 entry will be available in this stack m1 like this. Okay, when I'm calling the m2 method, so one m2 entry will be available in the Java stack. Whenever m2 method completes, then the entry will be removed from the Java stack, and whenever m1 completes, then m1 entry will be removed from the Java stacks here. Okay, so that is the purpose of this Java stacks actually. What is the use of the Java stacks here? So the methods will be executed on the Java stacks here. Methods execute on, okay, stacks here, first in, okay, last out here. That is a, okay, formula of this Java stacks here. Now next one here is PC registers here. Okay, program counter here. So what is the use of the PC registers? Very simple. Okay, for each and every method, okay, there will be one memory location. Okay, so for example, m2 is available in the 2000 address location, and for example this m1 method is available in the 1000 address location here. Okay, these PC registers will store the, okay, memory address of the methods. For example, in a class there are two methods. Okay, that's why two PC registers will be created like this, PC1 and PC2, and each and every PC register will store the memory address of the, okay, methods here. For example here, so 2000, so this is about the, okay, PC register 1. In the same way we have a PC register 2, and it will store the second method address. Let's take 1000 like this here. That means, for example, you may get out, so there are 10 methods in the class, then how many PC registers will be created? Okay, 10 PC registers will be created, and each and every PC register will store the, okay, memory address of the, okay, a separate method like this here. That is the duty of this PC registers here. Simple, it will store the memory address of the methods. Okay, that's the thing you have to remember. Next one, a native method stacks here. First of all, what is mean by native method? What is mean by native method here? So native method is nothing but C and C++ functions. Okay, what is the native method? I'm writing here C. Native method is nothing but C and C++ functions. Okay, if you want to execute C and C++ functions in the Java, okay, Java supports that one. So those C and C++ functions will be executed on the native method stacks. So these are similar to the Java stacks only. Okay, but in the case of native method stack, the native methods will be executed here. Same thing here, and each and every stack will be divided into several frames like this. Okay, and each frame a separate function will be executed here. For example, C function, we have function 1, and here function 2 will be executed. Okay, so that's the purpose of the native method stacks here. Same thing here. It is similar to the Java stacks only, but the difference here is in the Java stacks, Java methods will be executed. Okay, functions and methods are same. In the case of C++, we can call them as a functions, and Java we can call them as a methods. That you have to remember here. Now, here, so Java stacks means here we are executing the methods, and so Java methods, and native method stacks means there we are executing the C and C++ functions or methods. And once the function 2 is completed, the entry will be removed from the native method stacks, and whenever the function is executed or completed, the function 1 removed from the native method stacks here. This is about the native method stacks here. Now you may get doubt here. So in order to execute the C and C++ functions, we need C++ libraries, stdio.h, conio.h, etc. Some other support libraries we required. Then who will load the required libraries here for executing these functions of C and C++. Okay, so for that, if you observe, so by seeing this diagram, we have a native method interface. It is a program, so it will load the native method library. See this one, so native libraries with stdio.h and conio.h, etc. Okay, those libraries will load into the JVM by this native method interface. It is a program. I'm writing the things here, see. So it will load native libraries into JVM, Java Virtual Machine here. So that is the purpose of the native method interface here. That is a program. It will load the native libraries into the JVM so that we can execute the C++ functions into the Java as well. Okay, so that's the thing you have to remember. So this is about the thing. And finally, we have to discuss about the execution engine. So still we have to discuss about the conversion part here. So here the storage, we store the entire program and we split into the different parts actually. Now, so what is the use of the execution engine? So this is a main part. It will convert the bytecode into the machine language instructions here. Okay, so what is the duty of this execution engine? Converts bytecode into machine language instructions. Machine language instruction. Okay, that is the duty of the execution engine. See, so the execution engine contains the two components again. First one is a JIT compiler. Okay, JIT means just in time compiler. What is that one? Just in time compiler here. Next one, plus it contains the one more component called interpreter. Interpreter here. Okay, so the execution engine contains the two components. The first one is a JIT compiler and interpreter. Okay, so if you take any programming language, either C, C++, COBOL, Pascal, etc., .NET, etc., either it contains a compiler or interpreter, but this Java execution engine contains the two components called compiler and interpreter. So this concept is called adaptive optimizer. Having two components is called adaptive optimizer. Adaptive optimizer here. So why they introduced these two components actually? Okay, so here, so first of all, what is the difference between the compiler and interpreter? Okay, the compiler will convert the programming statements into the machine language instructions in a single step. Okay, in a single shot, it will convert entire program into the machine language instructions. So coming to the interpreter, so it will convert the programming statements into the machine language instructions line by line. It will read the first line and it will convert, and it will go to the second line, it will convert, etc. Okay, that will happen actually in the case of interpreter. Okay, so to enhance the speed of the Java execution, Java program execution, they introduce this JIT compiler here. Okay, if you use the only interpreter, what will happen? Okay, so it will execute the statements okay, slowly, one by one, right? It will impact in the performance of the application. That's why, so along with the interpreter, so they introduced the JIT compiler to enhance the speed of the execution. Okay, then so this compiler as well as the interpreter will execute the, okay, so this bytecode into the, okay, it will convert the bytecode into the machine language instructions. But so each and every part or each and every component, it will take care about the some a set of statements here. Okay, for example, here the JIT compiler will take care about the control statements. Okay, so each and every component will take a different task here. Okay, the JIT compiler will take the control statements. What is in by control statements here? Like if statements, loops, and okay, switch statement. Okay, so if these statements will be executed by the interpreter, it will take the time, so much time. Okay, interpreter is only for sequential statements, and a JIT compiler is for, okay, control statements like loops, switch statement, like for loops, etc. Okay, so that's the thing here. Now one more thing you have to remember here: the code which is executed by the JIT compiler, listen carefully once I am repeating, the code which is executed by the JIT compiler is called hotspot. Okay, what we can call it is called hotspot actually. Okay, they will ask me that what is mean hotspot in the JVM. Okay, so the code which is executed by the JIT compiler is called hotspot. Now see, so the compiler, what is the duty of this compiler here? It will execute the control statements like if statement and loops and switch statements, etc. What about the interpreter? So interpreter will take the, okay, sequential statements here. Okay, so interpreter will take the sequential statements here. Okay, what are the sequential statements? One by one. For example, we have a logic like this. We have a logic. Okay, so for example, here statement 1 and statement 2. In between we have for loop, and again we have a statement 3 and statement 4. Again we have a if condition. Okay, assume this is one code we have. So this code, okay, will be, okay, executed by these two components here. Okay, so in this, so what is the code which will be executed by the compiler, and what is the code which is executed by the interpreter here? Very simple. The code like statement 1 and statement 2 and statement 3 4 and will be executed by the interpreter, and the for loop and this if statement will be executed by the, okay, JIT compiler here. Compiler, and this is about the, so interpreter. Okay, they will divide the task here based on the conditions here and statements here. Okay, so this is about the, so the main part of the execution engine here is it will convert the bytecode into the machine language instructions here. Okay, so that's the thing here to remember. This is about the whole thing about the JVM architecture and all. Okay, so clear everyone? Any questions? Sandeep, Shirisha, and Rohini, any questions please? Hello?
No, sir. Yeah, you can carry on, sir.
Okay, okay, good. So next one here is, so Java download and installation here. Okay, how to download and how to install the Java. Okay, uh, okay, very important here, listen carefully. So first of all, you have to identify the operating system type here. Okay, how to identify the operating system? Right click on the computer, go to the properties, and you can see the, okay, so this operating system type, it may, so it may be a 32 or 64 bit operating system, right? So based on this operating system type, we have to download the JDK. Okay, now so go to the Google and search for the JDK download. So JDK 7 download. Okay, download this one here. So go to this one, Java SC development kit here, downloads. Okay, see, so there is a Java SC development kit 7U, and so each and every operating system will have the, okay, a separate JDK here. Now so here there are two things here. If you observe, so Windows, for example, if your operating system is a Windows, okay, you can download these two things here. Okay, so if your operating system is a 64-bit, and you can download this exe file. And if your operating system is a x86, that means it is a 32-bit operating system, then you can download the i586.exe here. So based on the operating system type, you have to download this one. So just okay, after downloading, just click on next. Automatically it will be installed your system. Okay, there is a default path program files. Okay, so no need to install. Okay,
What about Mac, sir?
sorry,
What about Mac?
see this one, Mac OS x86, we have x64. You can download this one here, Mac OS X x64 DMG. Okay, you can download and you can install here. Okay, and for example, if your operating system is a Solaris, and you can download this one, and a Linux operating system, you can download this one here. So got it, Shirisha?
Yes, sir.
Okay, now so download, and after installing, just click on next. Okay, nothing you have to do, just click on next. Automatically, okay, one folder will be okay created like this here. Go to the program files in the case of Windows, program files, and in the program file there is a Java folder. Okay, in the Java folder you can find the JDK, and in the JDK you can find the JRE. In the JRE there will be one JVM. I will explain like now here. See, so once you install the Java, okay, what will happen here is, see, so when you install the JDK, Java Development Kit, JDK means Java Development Kit here. Okay, Development Kit, Java Development Kit here, JDK. So when you install, what will happen? So one folder will be created inside the program files, that is a Java. So JDK is nothing but Java Development Kit. I'm writing here, see. So when you install the JDK, automatically, okay, one more component called JRE will be installed automatically. Okay, if you observe, go to the program files. Okay, there is a JDK. Forget about this one. I install later it is. Okay, not required. Delete this one. Okay, JDK. Inside the JDK, there is another component called JRE. See this one? JRE, Java Runtime Environment here. Okay, I'm writing here. See, JRE. What is the full form of the JRE here? Java Runtime Environment here. Java Runtime ENV environment here. Okay, inside the JRE, one more component called JVM is there here. Okay, JVM, Java Virtual Machine. So they'll ask in the interview actually, what is the difference between the JDK, JRE and JVM? Very important interview question it is. Okay, where I can see the JVM here, go to the JRE, click this JRE and go to the bin folder. Okay, you can see the Java. Okay, search with the Java here. Go to the types and search with the Java here. This Java here. So it is a program actually. Application, say it is a program. So this Java is nothing but JVM, Java Virtual Machine. Okay, so where it is available? Inside the JRE, Java Runtime Environment. Where this JRE is available? Inside the JDK. Okay, now, so along with this JVM, this Java Runtime Environment will have some other supported jar files. Okay, there is a rt.jar file. What it contains here? It contains the predefined classes and predefined interfaces, etc. Okay, Java comes with some predefined classes. If you want, we can make use of the predefined classes and we have to write the Java program. Okay, so those classes contains this rt.jar. Rt.jar contains all the classes, predefined classes, and nothing but Java library. Okay, so this rt.jar nothing but a Java library. It contains all the classes and interfaces, predefined classes and interfaces here. Okay, so that you remember here. Now along with this one, so there are other some okay supported files here. Okay, we don't require the supported files here, but remember, so JRE contains the JVM and rt.jar file and some other supported files here. Okay, this is about the JRE, and we discussed about the JVM just now, JVM internal architecture, and you can explain that one. And so what is the use of this JDK here? Okay, JDK contains the JRE. Along with the JRE, the JDK contains the some other tools. Okay, some other programs like so for development purpose we can make use of the JDK like this: Java C, Java compiler. Okay, and so we can use the Java profile. Okay, if you want to can see the bytecode instructions we can use, and if you want to can see the methods in the dot class file, also we can use the java p. And there is a jar command, java archive, for example. So I want to group a similar kind of dot class files into the one a package, a jar file, a zip file. Then we can make use of the jar here. And in the same way, if you want to can extract the jar file, we can use the jar command. Okay, anyhow we'll come to know later. Okay, one by one, this is about the jar. And java doc, okay, it is a one program. We can make this java doc command to generate the html document for the java program, java documentation comments. Okay, so anyhow we'll take one example on the java doc also. Okay, what is the use of this java doc here is, for example, I'm writing one program. Okay, so after that I'm giving that program to other developer. To understand that program, we have to write the java documentation comments on top of the class and methods, so that so the java developer can, okay, generate the java documentation comments, then java document based on the source code. Then he can read that okay, comments and description of that program, so that he can easily understand the things. Anyhow, so we can generate the html document for the java program also. Okay, that's about the java drag and etc. So there are so many, okay, so useful tools we have. In how will come classes you will come to know, so where we required and all. So this is about the, so the difference between the jdk, jre and jvm here, very important in the interview question. They will ask, definitely they will ask. Okay, now here, so I want to execute one program here. Okay, so next one here is like setting path environment variable here, setting.
Sir,
Yes, please.
sir, where does this API comes in JDK?
Okay,
API.
okay, so here, so we won't find any API in the JDK actually. So you can directly download from the net actually. See this one. Okay, what you're saying here is this API, that means this rt.java you're talking about, or normal Java API you're talking about.
No, sir, generally
Yes.
JDK combines of JVM and API, right?
Okay, JVM and rt.jar file here. Okay, so where you can see this rt.jar file you're asking, right? Yeah. So go to the JRE and there is a lib folder here. Go to the lib folder and there is a rt.jar file. See this one? rt.jar file. And if you want, you can extract this jar file. Let me open this one, copy and place into some folder, D drive and program, paste it here. You can see the all the classes here. Okay, go to that folder. I want to extract that one here, cmd. So go to the D folder and cd program, and here we have a three files it seems, .class file .java, but rt.jar file here. Now I want to extract that jar file. For that we have to use the jar command. Okay, extract verbose file. Okay, verbose means we can see the extracted content in the console. Extract to file, and what is the file name? rt.jar file here. Enter. Okay, it will extract. See this one, extracting all the classes, predefined class and interfaces here into the, okay, our folder like this here. It will take time actually. It will take minimum 2 minutes because there are okay, so thousands of classes we have in the Java library. Okay, extracted here. And one more thing here is, so you can go through this one, com dot, okay, oracle dot, some other, so neo, buffer secrets, etc. So these are the classes here. So these are the package is nothing but, yeah, I will explain one more thing here. See, we have a class 1 and a class 2 or class B, whatever you can take here. Okay, so what they did here is, so they combined related classes into the one folder called package. Okay, package contains the, okay, a number of classes here. The group of classes is nothing but a package. Package is nothing but a folder here, package 1. In the same way, so they will take one more package like this here, and here class 3 and class 4. Class 3 and class 4. and they grouped this related classes into the some more package called package2. Package nothing but folder. Okay, they come and related okay classes into the one package. In the same way in our real time also we have to group related classes into the one package. Now, so the combination of the collection of package is nothing but a Java library. Okay, what is meaning of the Java library? So the combination of all the package is nothing but a okay Java library here. Package contains the okay classes. Okay, there are group of classes nothing but a package, and the group of package is nothing but a Java library here. In the same way, go to this extracted here. Okay, we are extracting here. Still, it is extracting. See now. So here, com is one folder. Okay, under com there is one more folder called Oracle. Under Oracle folder there is a one more folder called Neo, and this contains here classes here. These are classes. See, a group of classes contains. Okay, these classes are available in the Neo package, and so this is all available in the Oracle, and Oracle is available in the com here. Like that they divided actually. Okay, this is called Java library, and you can see this Java API from the net also. You can download the net, you can download the Java 7 API from the okay so net, and you can use the Java. Anyhow, all that is later, but here you can see this one Java 7 API. Open this one, click this first link, overview of the Java platform SE7 Oracle documentation. Okay, so this is about the API documentation here. Okay, so I told right, so there is a Java documentation comments. If you observe, so there is a command called Java doc. Okay, so we can use this Java documentation okay command for generating the okay, Java API like this one here. So this is about the Java API for Sun Microsystem from Sun Microsystem. So while developing the Java classes, they have written the Java documentation comments. That's why they are able to generate this Java documentation okay API here, API they developed here like this. If you observe, for example, here say java.lang package. Okay, java.lang package we have. Okay, package contains I told that. So Java is one folder. In that folder there is a lang is one more folder. Under that there is the interfaces. Forget about the interfaces, and here there is a classes here. That means a group of classes okay they combined and they made it as a package. There is nothing but a java.lang package here. Okay, go to this class here. There is a string class. Okay, so they given the okay the description about that class, and the corresponding methods of that class here. Methods character at concat okay or thing here equals method etc. Okay, these are the Java documentation for the Java API. You can go through this documentation and you can okay search for the content here, extra information. If you want extra information, you can go through this one here. Okay, this is about the Java documentation here. So clear, Sandeep? Any questions?
Yes, sir. No questions.
Okay, that's the thing here. See this one Java dot okay, so lang still yeah lang, and after that we have a so class and interfaces here. Okay, these are the things you have to remember here. Now next one here is okay setting the path environment variable here. Okay, what is the use of the okay path environment variable here? Okay, very simple. So go to this folder only. Okay, I'm stopping this one. I already done here. Exit. Okay, this is about the so you can see the all the things here. Okay, I'm removing this one here. Okay, it will take the time to remove the other thing, not required. I'm removing this dot class file. Okay, rt.jar not required for us, and you can remove this one also, not required. Deleted here. We have only one source code, source file here. Go to that folder. Okay, D drive, CD programs. Okay, so I want to compile this one Java C. Okay, what is the class name we have? Hello.java. Okay, it is compiling here, no issues. Okay, that means the operating system is able to identify the what is a Java C here. Now what I can do is I'm going to the computer properties. Okay, there is option called advanced system settings, and there is option called environment variables, and there is a path actually. there is a path. Remove this path here and click on OK and click on OK here and try to close this one. Open the new session, CMD. Okay, so go to the D drive, CD. Okay, program. We have a two classes, right? Two files. Okay, dot class file. I want to delete the one dot class file here. Okay, there is a dash command, not Java command. Delete. Okay, deleted. Okay, we have a only one Java file here. Now, what I can do is I want to compile the Java program here. Java C hello dot Java. Okay, what is the output we are getting here? Java C is not recognized as an internal or external command here. Why we are getting this one? That means the operating system is unable to identify the what is Java C. Okay, so to execute Java program from anywhere in our system, you have to set the path actually, so that the operating system will go to that path location and it will search for this command, whatever we are typing here. If it is find, so it will execute that command here. Okay, so presently I didn't set any path environment variable. That's why the operating system is unable to identify the Java C here. Now, what we have to do here is we have to create one path environment variable here. Click new, all caps letter path. What is the location here? I'm giving the location. Okay, go to the C drive, program files, and Java and JDK, and go to the bin folder. Here you can see the Java C, Java Talk, Java P, etc. Okay, we can use the up to the bin folder here. Okay, when I'm issuing any command like Java C, Java and all, so the operation will come to this folder and it will search for that command. If it is there, it will execute the program and all. Okay, so that's why I'm giving the up to JDK bin here. So what is our variable name and ends with the semicolon here, not required, but so if you want to add one more path, you can ends with the semicolon and add one more path. Okay, click OK here and finish. Okay, so close the current session and go to the next session, CMD, D drive and CD program, and here we have only one .java here. Now, so Java C hello dot Java here. What is happening here? So when I'm entering this one, the operating system will go to the the path location. Okay, the Java C is there, then it will execute the Java. It will compile the Java program here. Okay, perfectly valid. Now Java hello dot here. Okay, Java is a simple to learn we are getting here. Okay, so that means if you want to execute Java program from anywhere, okay, we can make use of the path environment variable, that is a operating system variable. Okay, whenever you're entering any or when you're typing any command, so the first operating system will look the the path location. If it is there, it will identify and it will execute that command. Otherwise it will throw the exception saying Java C or other command. If it is not finding the, it will throw the error message like so the command is not recognized as an internal or external command. Okay, so that's the thing here to remember. That is about the Java path environment variable here. Okay, so clear everyone? Any questions? Rohini, do you have any questions?
No, no questions.
Okay, good. So tomorrow we'll discuss about the this Java program with explanation for each and every keyword. Okay, what is a class, what is a program name we have to take, and naming conventions also we have to take. Okay, so tomorrow we'll discuss and we'll go with the Java identifiers and the Java keywords and data types, and later we'll go one by one. Okay, yeah. Yeah, thanks everyone. If you have any question, please ask me. Otherwise, we'll meet tomorrow at same time, 8:30 to 9:30. Okay. I will upload this video.
Okay, sir.
Please go through this video and please practice. Spend at least 1.5 hour or 2 hours a day. Okay, so that you can get the confidence. Okay. So that's my suggestion. Okay, please go through that one. Okay. Yeah.
Okay, sir.
Yeah. Thanks. Yeah. Thanks, Sandeep, Shirish, and Rohini. We'll meet tomorrow. Bye. Take care.
Okay, sir. Bye, sir.
Thank you. Thank